Now we are going to add the loads to our model. So we have two concentrated loads and one uh, distributed load. And we have for the concentrated load P1 and P2, we have 6 and 4, 6 for P1 and 4 for P2 for the dead load case. And we will go to the software right now. And we have uh, different kinds of loads. So we have joint load. Joint load is applied to the joint directly. Point load is applied to the element. It can be at any distance through the element. And you have the distributed load is applied also to the element. So if we go to uh, the figure here, we can find that we have P1. P1 is characterized as point load. So I will go to point load here and I will add element AB, and the distributed load direction will be Y, and its okay, its value is okay -6 for the dead load and -2 for the live load. So I will add here, the case here is dead load, so I will add -6, and the location is 50%. Okay, and you can add the location as a number in meters in your unit, and you can add this in percent like this. Okay, and we now will go to the live load, and I will do the same element AB, and the value will be -2 in this case, -2, and the location at 50% of the length. Okay, we can show the load now by clicking here, and you can say show dead load and the live load. Now we will go to the next load, which is P2. P2 is 4 for dead load and 3 for live load. Okay, and P2 is applied to a joint D, so this can be characterized as a joint load. So I will go to joint load here, and I will click, and we need joint number D for joint D, and we have dead load and live load. We have dead load and live load. Okay, I forgot to talk about this. We have three kinds of loads. L mean load, mean force, like something in kilonewtons, pounds, or something like this. And we have displacement. Displacement can be simulated to can be used to simulate the settlement of foundation or application like this. And we have mass also, and the mass is used to perform seismic analysis. So we will use load. Okay, we use load as we used this before, and we have the load will be in the y direction, and we have -4 dead load and -3 live load. So we have -4 here. Okay, and for the live load, I will repeat the steps. So we have joint D, live load. Okay, and the value is uh, -3. Okay, exactly -3. So I will close this now. Okay, so we can see here that we have -3 in dead load and -4 in live load. And the third load that we have is the distributed load, triangular distributed load. The dead load is 6 and the live load is 4. So I will go to distributed load here, and I will click here. Okay, and we have this load is applied to joint or to element CD, this element here. Okay, so I will go to element CD and start to apply this. So I will go to element CD here. Direction is Y, and the start value is 0, and the end value is equal to uh, okay, -6 for dead load and -4 for live load. And we have are here in dead load, so I will select -6 like this. And we don't need to change, you don't need to change the start location and the end location, because the element is distributed over the full length of the beam. But if you have the load distributed in a specific part on the beam, so you need to identify this. And for the live load, we will do the same. So we are talking about element CD, and we have the start value is 0 and the end value is -4, as we can see here. So -4. Okay, and I will close this. So we have dead load here and live load here. So now we have our full model. We define the geometry, we define the section and material, we define the boundary condition. Then I defined the load case, the load combination, and finally I defined uh, the loads. Okay, and also we define the supports, as we can see here. Now we will go and solve the model. We'll ask you to solve a single load combination or batch solution of market combinations. So I will include this option here and say solve. Okay, say okay. So now our model is solved now, and we have this new group of tables. Okay, so here we can see the joint reaction. So if you go to the table like this and expand these things here, okay, okay. So it will give you the y value, the y value of reaction at joint A, the y value of reaction at joint B, and the reaction at joint E. Okay, as you see here. Okay, and we have 0 reaction at joint X because we don't have any horizontal forces, and we have moment at joint E. It gives you the maximum value for all the load cases and load combination, sorry, and the corresponding load combination number. Okay. Okay. Now we will go to the graphics. So if you go to this blue box here, you can show the joint reaction on the figure. So I will select joint, the X reaction, the Y reaction, and the moment. Okay, and you can see this here. Also can include the magnitude to show the values. Okay, okay. And if you want to remove the loops, you don't need to show the loops, so you can just say make this. Okay, and here I will go back. Okay, so I will remove this now. Then I will go to members. And in the members here, I can show the axial load. We don't have axial load. We can show the shear force as you see here. Okay, and the shear force as you see, uh, like reasonable. Like if you try to calculate this by hand calculation, it will be, you will find that it is reasonable. We can show also the magnitude. We can increase the scale factor like this. Okay, and finally the moment, we can show it from here, and this is the moment diagram. Okay, okay. So now we solved the model and show the results. Okay, like the forces. Something else that we need to show is the deformed shape. It is very important. So if we go to deflection here and we say like show the deformation at load combination here. Okay, we can select the load combination that we need to show the load for, and I select this for example and say apply. Okay, but like I will remove the moment diagram first. Okay, now we can show the deformed shape due to the load combination alone. Okay, can say we can show this one here. Okay, we can also play with the scale factor. Okay, good. So this was the how can you show this? This was the method that you can use to show the forces and deformed shape of your model. Thank you guys. So this is what we have for this example. See you in the next example. Thank you.